Hello and welcome back, folks. So I'm really sorry that I deleted few of the videos in this series, but I feel they weren't doing the topic much justice. So I'll be doing a brand new take on them, and hopefully they'll be much better explained this time. Okay, so in the last video, I was going through this example of throwing a dice 3 times and finding the probability of a sum of 7. Now in that, I constructed this sort of sample space, and the sample space was basically a three size tuple of numbers from 1 to 6, and my goal was to find out how many ways can they sum up to 7, in which I introduced the concept of a generating polynomial and found out that the number of ways you could do that was 15. Now that I know that the number of ways you can do that is 15, all you have to do is, well, sum up the probability of each of those 15 things. But the thing is that the probability of each of these things is something that we assign. And here I have followed the classical definition of probability and assigned each of these, each individual triplet, I have assigned it a probability of 1 over 216. Why? Because all the triplets are equally likely to occur, and hence we found the probability of a sum 7 as 15 over 216. Okay, so I hope this illustrates the point I want to make, which is I have used the axiomatic approach over here, but the thing is, the individual probabilities for some basic elementary events that I've assigned, that is totally on me. And in that case, I don't care whatever model you follow, but they sure should follow the rules of the axiomatic probability measure. Okay, I discussed the compatibility with the classical approach via an example, but now I'll be discussing the compatibility with the frequentist approach. And I won't be using examples, but I'm going to be going all theoretically over here. Okay, now suppose you have an experiment with a sample space omega and an event space f. So this will only be certain subsets of omega. I'll get back to what this is in a later video. But if this experiment is repeated multiple times, so let's say we have this experiment which takes outcomes from this sample space omega, you do it multiple times, say you do it n times, and n is a pretty large number, so it will be 1000 or 10,000. Basically, let's say we are taking the ratios, we are taking this ratio as n tends to infinity. And now any event a that is from the class of subsets, if it's observed any times, then the probability of a, we assign that as na over n. Now suppose the event that a I'm considering, it's something basic, like let's say the occurrence of one of these triplets. So this is a basic this is an elementary event, right? This is the smallest outcome this is the outcome that you're finding. Okay, now that I've assigned a probability of a to something, it has to follow 3 axioms, because that's the framework we are working with. Now, does this thing follow the axiomatic approach as well? Let's find out. Now, PA is na over n. This is greater than 0. P of omega, now omega is the certain event. So, if I conduct the experiment n times, then obviously the omega being the certain event will also occur n times. That's the definition of omega. And so P of omega will be 1. Alright. Now if A and B are 2 events, they are mutually exclusive, that is no common elements. And if one occurs, then the other will not occur. That's what mutually exclusive is. And so the number of times A or B occurs is the number of times A occurs plus the number of times B occurs. There won't be any overlap between them, so there won't be any trial where A and B will occur together. That sort of stuff just won't happen. And so you can just add up the individual occurrences, not a problem. Now P of A union B, that's basically na plus nb over n. If you split the fractions, then you will see that it is equal to the individual probabilities of A and B, which satisfies the third axiom. And so with that, we have established that we can use any experimental results from the frequentist approach to assign numbers to our probabilities that follow the axiomatic approach. So in the previous video, I just demonstrated that with an example of how we'll use classical approach to assign numbers, concrete numbers. In this case, I have just illustrated how we'll assign concrete numbers we found experimentally and make them, and they will follow the axiomatic three axioms by themselves. That's not a problem. Alright, in the next video, I'll be discussing something called the equality of events, and it has some caveats which I'll also illustrate. Until then, see ya and have a nice day.